Hi there. Well, we're going to look at three sections in this video, 3.1, 3.2, and 3.3. In 3.1, it talks about divisibility rules and multiples. So we'll talk about divisibility rules first, and then we'll talk about multiples. Neither one of them are hard concepts. The divisibility rules, we're going to look at just some certain rules here, ones that deal with 2, 3, 5, 6, 9, and 10 is what they would like for you to know in this section. How do you know if a number is divisible by 2, 3, 5, 6, 9, or 10? And there's and then what this does is it makes reducing fractions a little bit faster. If you know what number to divide both the numerator and denominator by, you can reduce your fractions a little bit quicker. So let's look at the number 2. How do you know if 2 would go into a number evenly without a remainder? Well, in order for 2 to go into a number, that number has to, the ones digit needs to be either a 0, 2, 4, 6, or 8. All right, so what does that mean? Let's look at some examples. If we have 4, 3, 6, all right, would 2 go into that? Well, you look at the ones digit, which is right here. That's that first digit there. And here, the ones digit is 6, all right? So the answer would be yes, because it ends in one of these numbers here. When you end in one of these numbers, we say that this number is even. So any even number is divisible by 2 with no remainder. It would go into it evenly. Let's say that we have 1058, 1058. Is this divisible by 2? Well, the ones digit is an 8, okay? And so because it's here, it matches here, we call this number 1058 even because it ends in one of these digits here. Any even number is divisible by 2. So this one would also be yes. Let's look at another example. 2,487. Is this divisible by 2, which means does 2 go into it without a remainder? You look at the ones digit here. The ones digit is not even, okay? This is not an even number because the digit, this ones digit does not end in a 0, 2, 4, 6, or 8. Because it's not one of these, the answer is no. 2 would not go into that evenly. You would have a remainder. All right, so the 2 isn't too bad. You just have to glance at it, knowing then if this is 0, 2, 4, 6, or 8, then the answer is yes, it is divisible by 2 by just glancing at it. It just needs to have that ones digit, one of these numbers. Okay, number 3 takes a little bit more effort. How do you know if a number is divisible by 3? Or maybe I'll put these guys in little boxes here. All right, how do you know if a number is divisible by 3? Well, what you do is you add up the digits. So it's another way of saying that is you find the sum of the digits. And if the sum of the digits is divisible by 3, the number is divisible by 3. So the first step you need to do is add up the digits. Individually, you add them up. We'll do some examples and you guys will be fine. You add up the digits, and if the sum is divisible by 3, then the number is divisible by 3. All right, so you add up the digits. Okay, and then if the sum you get is divisible by 3, then the number is divisible by 3. It's really not, it's maybe as complicated as it sounds. So let's take the number 2,300, that's right here, 2,310. Well, we're going to add up the digits. What does that mean, add up the digits? You take 2 plus 3 plus 1 plus 0. And you could probably just do that. You can do that without writing this out. Well, you get 2 plus 3 is 5, plus 1 is 6. 6 is divisible by 3 evenly. Because this is yes, it goes in twice evenly. This is yes. 3 would go into that number evenly. So if it was a numerator and denominator, you might be able to divide them by 3 if they're both divisible by 3. Okay, let's look at another example. Let's do 1,000. I had some other ones here. Or no, how about just 165? Is that divisible by 3? Well, you find the sum of the digits, 1 plus, you find the sum by adding. 7 plus 5 is 12. Sure, 3 goes into 12 4 times. It goes even. So it's yes. So that means 3 goes into that one. Okay, let's try one more before we go to 5, and 5 is pretty easy. All right, how about 1,034? Would 3 go into that evenly? Should you even waste your time seeing if 3 would go into that evenly? Well, we'll take 1 plus 0 plus 3 plus 4. I add these up, I get 8. 3 does not go into 8 evenly. It goes into 6 and it goes into 9, but it doesn't go into 8. You'd have a remainder. So this is no. 3 will not go into that number without a remainder. All right, it won't go into it evenly. All right, so actually the 3 is one of the harder ones. So, it doesn't really get much harder than that one. Okay, let's look at our next one, and that would be the number 5. How do you know if you could divide a number by 5? Well, this one's pretty simple. Let me try to move this up a little bit. There we go. In order to be divisible by 5, you look at the last digit. So you look at the ones digit again, just like you did with the 2. The ones digit must be a 0 or 5. That's it. So you can do this at a glance. So here, 2005. The ones digit is a 5. So this one is yes. 1707. The ones digit is a 7. So the answer is no, it is not divisible by 5. Let's say 8,070. The ones digit is a 0. Yes. So again, to be divisible by 5, the ones digit, this digit here, must either be a 5 or a 0. And then 5 will go into it evenly with no remainder. So that one's pretty easy. 2 and 5 can be done at a glance. 3 takes a little bit of work, but it's not too bad. All right, let's look at the number 6. How do you know if a number is divisible by 6? I can turn this over. Yeah. If a number is divisible by 6, and we're going to do some more examples here. If a number is divisible by 6, to be divisible by 6, it has to be divisible by both the 2. So you have to follow the rules of the 2, which means it has to end in 0, 2, 4, 6, or 8, and 3. So then also the sum has to be divisible by 3. So it has to be both the 2 and the 3 to be divisible by 6. I'm given an example. Let's say we have 4,260. Is this divisible by 6? Well, it is divisible by 2. All right, so it's divisible by 2. That's a yes, because the last digit is either a 0, 2, 4, 6, or 8. So it is divisible by 2. Is it divisible by 3? Okay, so question mark, is it divisible by 3? Well, we're going to add up the digits. And we get 6 plus 6 is 12. 12 is divisible by 3. Both are yes, so this is a yes. It's divisible by 6. So you have to do both the 2 and the 3, and then it's divisible by 6. All righty. And the next one we were going to go through is the 9, and we'll do more examples. 9 is it's the same rule as the 3, except for the sum needs to be divisible by 9 rather than 3. As an example, okay, well, the sum must be divisible by 9 this time, rather than the sum being divisible by 3. So if I had 2,340, would 9 go into that evenly? Well, let's go ahead and we're going to add up the digits. So we're going to take 2 plus 3 plus 4 plus 0. So for both the 3 and the 9, you've got to add up the digits. Here you get 5 plus 4 is 9. Well, 9 is divisible by 9. You get 1. So the answer is yes. 9 is divisible by 9, so this is a yes. So it's just like the 3. You sum up the digits, but rather than dividing your answer after your sum by 3, you divide by 9. And if it's yes, then it works. If not, no. And our last one is 10. 10 is real easy. This is done at a glance. The ones digit must be 0. That's it. So if you have 5,780, the answer is yes. The ones digit is 0. If you have 756, the answer is no. 10 will not go into it evenly. Something else would go into it evenly. 2 would go into it. Would 3 go into this? Well, you'd have to add up the digits and see. 7 plus 5 is 12, plus 6 is 18. 3 goes into 18, so yeah, 3 would go into it. So 2 would go into it, 3 would go into it, so 6 would go into it. But 5 would not, because it doesn't end in a 0 or a 5, and 10 would not. All right, so they're not too bad. They're actually there to help speed things up a little bit. But we're going to look at a couple of examples before we go on to 3.2. And you guys can always, if you catch on to an idea, you can always just fast forward it. All right. And then we're going to have to look at some multiples. And we might look at multiples here. After I'm going to do the divisibility rules on the other side. See the ones I like. Okay. All right, let's look at number 12. Number 12, determine whether 1,240 is divisible by 10. To be divisible by 10, it has to end in 0. This is done at a glance, so the answer is yes, because it ends in 0. All right, the ones digit is 0. Okay, let's look at, 13. Determine whether 183 is divisible by 6. Well, you have to determine, first off, it has to be divisible by 2. It's not. So we can stop right there. We don't even have to see if it's divisible by 3, because to be divisible by 6, it has to be divisible by both 2 and 3. That is not a 0, 2, 4, 6, or 8. It's not an even number, so it's no. We're done. Let's look at 14. Is this number divisible by 2? You go to the ones. If it's a 0, 2, 4, 6, or 8, the answer is yes. Well, obviously, the answer is yes. That last digit makes this number even. And therefore, all even numbers are divisible by 2. All right, let's look at number 15. Is this number divisible by 9? Well, we're going to add up the digits, and we're going to see. So here you get 17 plus 1 is 18. Is 18 divisible by 9? Yes, it is. So that means this number is divisible by 9. All righty, good. Well, let's look at maybe some of these 16, 17. I don't know if we'll do 18 or not. We'll look and see. Given this number, which one of these would go into it evenly? And there's more than one. Well, maybe there's more than one. Here is it divisible by 2. Well, this digit is not 0, 2, 4, 6, or 8. So it's not 2. What about, and if it's not 2, it cannot be 6. Because 6, you have to have both 2 and 3. So if it's not 2, it's not 6. So by answering some of these earlier ones helps you to answer some of the later ones. But could it be divisible by 3? Let's add up the digits. 1 plus 6 plus 6 plus 5. So you get 7 plus 6 is 13. 13 plus 5 is 18. Is 18 divisible by 3? I wonder if I could turn on the lamp there. Oh, well. And the answer is yes. 18 is divisible by 3. It goes into it evenly. So we have 3 will go into that number. Let's look at some other ones. We know that 2 won't. 3 does. What about 5? Will 5 go into this number? You look at the last digit. If it's 5, or excuse me, the ones digit, if it's 5 or 10 or 0, sorry, if it's 5 or 0, then 5 will go into it. It's a 5. The ones digit is a 5, so 5 also goes into that number. We know 6 will not work because 2 does not work. So you'd have to have both the 2 and the 3 here, and if you do, then 6 goes. What about 9? Well, we already have our sum. Is this divisible by 9? Sure it is, twice. So 9 will go into that number evenly. What about 10? Well, here, does it end in a 0? No. So you're done. Those are the only 3 that go into that number evenly using the divisibility rules. Okay. All right. Let's try one more, and then we'll look at the multiples before we go on to 3.2 and 3.3. Okay. Here is it divisible by 2? Well, this ones digit is a 0, which makes this an even number. So yes, 2 goes into it evenly. What about 3? Well, 4 plus 3 is 7, plus 2 is 9, plus 0 is 9. Well, 3 goes into 9, so 3 will go into this number because the sum is 9. What about 5? To be 5, the ones digit has to be a 0 or a 5, which it is. What about 6? If you have 2 and 3, you have 6. What about 9? Well, you look at the sum that we had to do for the 3. Does 9 go into 9 evenly? Yes. 10, is the last digit 0, or is the ones digit 0? Yes. So 10 also works. So all of these numbers would go into that one evenly. Okay, so I think that's probably all we're going to do on the divisibility rules. And again, if you have any questions on that, you'll have to ask me. What we're going to look at now in this section, the last thing is pretty simple, and that's finding multiples of a number. So they're going to ask you to find multiples. And again, it's not really too difficult. Let's say you have the number 5. What are the first 10 multiples of 5? So, and they're going to even list, they're going to even tell you, find the multiples using these numbers. All they want you to do is you take 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. I am finding multiples of 5. These are multiples of 5. 5 times 5 is 25. 5 times 6, and we'll look at another way of doing this. 5 times 7 is 35. 5 times 8 is 40. 5 times 9 is 45. It's more tedious than anything. And 5 times 10 is 50. These are the first 10 multiples of 5. All of these are divisible by 5. All of them are. And notice that as I go from one to another, I'm just adding 5. I'm adding 5 more. Multiplication is just fast adding. I'm just adding 5 more each time. And so that would be the first 10 multiples of 5. Let's see, what would be the first 10 multiples of 15? Ugh, you're thinking, oh, yuck. So you would take 15 times 1. So you have 15 as our first one. 15 times 2 is 30. These are multiples. And maybe I should put multiples up here. Okay, multiples. All right. Then we have 15 times 1, 15 times 2, 15 times 3. And then what happens here is that if you notice, you're just adding 15 each time. And so you can add 15 and get 60. And then add 15 and get 75. If you don't want to go 15 times 1, 15 times 2, 15 times 3, 15 times 4, 15 times 5, you're just adding another 15 when you multiply by one more number. So that gives you 90. And then add another 15. Add another 15. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. Add another 15, add another 15. Obviously, 15 times 10 is 150. Okay, so those are multiples when they ask. Those are the first 10 multiples of 15. And each of these is divisible by 15. So multiples will be divisible by this number here. All righty. Pretty easy to find the multiples. It's more a multiplication issue than anything. All right, so now what we're going to do is we're going to look at our next section. And our next section deals with, and we'll look at some samples. Just a few notes here before we look at the worksheet, is what's a prime, what's a composite, and what's factorization. So these are the 3 ideas in section 3.2. Those are going to be in that section 3.2. A prime number, well, is a number that only one in itself, when you multiply them together, will give you that number. So in other words, 3 is a prime number. So we're going to talk about the primes first. Because only 1 times 3 will give you that number. You're going to be building trees, obviously. Maybe you've done these before. 7 is a prime number because only 1 times 7 will give you 7. There's, we could keep going on and on. 11 is a prime number because only 1 times 11, that's you can't really break it down using other numbers other than 1 in itself. 1 in itself. Okay, what would be the only even prime number? All right, and that would be the number 2. 2 is the only even prime number. All the other ones are going to be odd, but not all odds are prime, but every prime will be an odd number except the number 2. All right. And then I've got all these ones here. What about the number 1? Okay. The number 1 is not prime. Okay. And is not considered composite, which we're going to talk about. So we'll come back and talk about the number 1 after we talk about composites. So these are your prime, and your only even prime number is 2. Composite. What are composite numbers? Composite numbers can be broken down with numbers other than 1 and 3. Okay, and we'll come back and talk about those. So here we've got, like 6. 6 is a composite because not only does 6 times 1 give you 6, but also 2 times 3 gives you 6. You have another combination. So the factors of 6, you've got 1 times 6 gives you that, but also 2 times 3 gives you that. Okay, so these are called the factors of 6. Okay, let's look at another one. Let's look at 12. 12 is composite. You can have 6 times 2, okay? Or you can have 4 times 3. Or you can have 1 times 12. You'll always have 1 in itself in your list. These are the factors of 12. All right, those are your factors of 12. Numbers that when you multiply them together, you come up with this product here. All right, so these numbers are called factors. And factors, when you multiply them, give you the product. So these are factors. All of these are the factors. If it's prime, the only factors you're going to have are 1 and the number itself. These are the factors of 6. So if it's a composite, your factors are more than 1 and itself. It could be 2 and 3. All right. So again, these are called factors, and the factors can give you the product when you multiply them together. All right, so let's look at some other composite numbers. If they ask you, let's back up. If they ask you for the factors of like 6, you would write 1, 2, 3, and 6. All right, so you would list these numbers here. The factors of 12, 1, 2, 3, 4, 6, and 12. Don't forget about the 1 and the 12. Don't forget about the 1 and the 6. All right. If it's a prime, it's really easy to find the factors. It's just 1 and 3. But here, you've got your, 1, 2, 3, and 6. And I don't know if my math lab's going to make you put them in order. They may not. You may be able just to do any order. You may be able to go 2, 3, 1, 6. I encourage you not to forget the 1 and the 6 or the 1 and the 12. All right, let's look at another one. How about 40? Okay, I do know that 40 is composite. I do know that 2 goes into it because it's even. It's got a 0. I know that 10 is going to be a factor. And so some of those divisibility rules might help you with this. So when you're trying to list the factors, well, we know we've got 1 and 40. Okay, so we've got 1 times 40. Another factor group could be 4 times 10. All right, that gives you 40. We know 2 goes into it. So 40 divided by 2 is 20. So 2 and 20. Let's see, what else have we got here? 2 and 20, 4 and 10, 8 times 5. Well, how did I know that? Well, it's divisible by 5 because it ends in a 0. So I know that 5 went into it. So if I take 40 divided by 5, I get 8. So we've got 1 and 2. What about 3? Would 3 go into that? Would 3 be a factor? Well, if you add up the digits, 4 plus 0 is 4. So 3 does not go into it because 3 does not go into 4, which means 6 won't. All right, so you can kind of use those divisibility rules to come up with your list of factors. Sometimes it might take a little bit of time to get them all, depending upon how large the number is. But once you get these here, you'll have 1, 2, 4, 10. I'm going ahead and listing them in order. Oh, I missed 8. No, I'm not going to list them in order then. Well, okay, fine. I'll erase it. 1, 2, 4. I'm going to cross them off. 5, 8, 10, 20, and then 40. Okay, so that would be your list of factors of 40. Because 40 is composite, because you can break it down into just to other numbers other than just 1 in itself when you list these factors. So hopefully in my math lab, you'll get some of these where they say, what are the factors? Since it's prime, it would just be 1 and 11. Or 1 and 7. But when you get into some of these composites, it takes a little bit more time to come up with all of the different combinations that when you multiply them, you come up with with this number here. But these are the factors, and these are composites as opposed to primes. Now let's talk about the number 1. The number 1 it's not prime or composite. It's just kind of off by itself. So if they give you the number 1 and ask you, is it prime, composite, or neither, depending upon how you want to pronounce it, is it prime, composite, or neither, say neither. All right, just the number 1. So the number 1, let me move this up. The number 1 is not prime and it's not composite. And again, the only even prime number is 2. All the other ones, all the other evens will be composite. But then also some of the odds, like 9. 9 is a composite number because you've got 3 times 3 and 1 times 9. So some odds are composite, but these primes will be odd except for 2. All right, okay. Factorization. So let's look at some facts. We kind of talked about this factorization, but now we're going to talk about prime factorization. And then we'll do some more examples of all of this. Prime factorization. We're going to start with, let's do 40, okay? Let's do the number 40. What's the prime factorization? I like the trees. There's other methods, but I think the trees are the easiest. So we have these branches. Pick any 2 numbers that give you 40. And you could use 8 and 5 or 4 and 10. It doesn't matter. Or 2 and 20. You'll ultimately get the same answer no matter what you start with. Let's do 10 and 4, because I know we have a 10 and a 4. These are not prime. So we're going to break these down. 10 is 5 times 2. And once you break it down, it's kind of nice to cross it off so that when you write your answer, you don't try to include a number here. The 4 can be broken down into 2 times 2. Now, are these numbers all primes? Yes, they are, because none of these can be broken down other than one in themselves. So the prime factorization of 40, we're going to write it two different ways, is 2 times 2 times 2, 1, 2, 3, times 5. That's the prime factorization. You have broken these into factors that are all primes, and if you multiply these prime factors together, you'll get 40. Now, it also can be written 2 cubed times 5. All right, 2 cubed times 5, because we've talked about exponents. All right, either one should work. Either of these should work. All right, let's try another prime factorization. Well, let me see. Okay, let's look at some of these. We're going to look at some of these examples. All right, here's some. Let's list all of the factors of each number. Okay, well, if we look at this one right here, what are the factors of 23? Well, 23 happens to be a prime number. So the only factors of 23 are 1 and 23. Okay. But what about something like either 80 or 250? Let's look at 80. All right. Let's look at the 80 and see how many factors we've got. I don't think we did that one. We did 40, but I don't think we did 80 earlier. No, we didn't. We did 40. All right. So 80, you have 1 times 80. Those are two of the factors. Start with that one always so you don't forget it. Now, I know that 2 goes into that. 2 times 40. Okay, I'm listing the factors of 80. Numbers that multiply together that give me 80. What about 3? Can I do a 3 right here? Let's see. 8 plus 0 is 8. 3 does not go into 8. So 3 is not a factor. What about 4? Well, 80 divided by 4 is 20. And you could do that on your calculator if you needed to find out the 20. What about 5? Would 5 go into there evenly? Sure, because it ends in a 0 or a 5. 5 times, let's see, it goes in 116. Okay, all right, so we're moving right along. What about 6? Would 6 times something give you 80? Well, no, because in order for 6 to work, 2 and 3 would have had to have worked. So we don't need to mess with 6. Now 7, there's really not much of a rule for 7. You could just take 80 divided by 7 on your calculator to see, but 7 doesn't work. What about 8? 8 times 10. All right, so I'm just going through the list. Notice my numbers, I got 9 and that would be it. Does 9 go into here? And it does not. All right, because 9 does not go into the sum of these two, which is 8. So you're done. All right, so those are your factors. And I just started with 1, and then I went to 2, and then I tried 3, then I tried 4, then I tried 5. All right, so that's one way of doing this. And then I tried 8 and then 9. If I were to do 10, I'm just moving back up. the row. Okay, so good. So those would be the factors. You would just list them. You would list 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80. It's a little time consuming, but it can be done if you just want to do it this way. And I don't think I gave you that many of them, so you should be okay. So that's how you list all the factors of a number. Go through, start with 1, then 2, 3, no, 4, yes, 5, yes, 6, no, 7, no, and okay. All right, and you'll get it. All right, so then what we're going to look at is they want to know, are these numbers prime, composite, or neither? So going through here, 2 is prime. It's our only even prime number. 14, 2 times 7. 2 goes into it because the last number is 0, 2, 4, 6, or 8. So this is composite. 31. 31, what goes into 31? Let's see. You could go through your divisibility rules. 2, no. 3. 3 plus 1 is 4. No. 4, no. 5, no. 6, 7, no. So this one would be prime. Okay, 31 is prime. Again, just using the divisibility rules and seeing if a number would go into it. Number 1 is neither. Okay, 61. Well, let's go through your divisibility rules. Not 2, 3, add them together, you get 7, so no. 4, no. 5, it's not a 0 or a 5, this digit. 6, well, if 2 or 3 don't work, it's not going to be 6. 7, no. 8, no. 9, add them together, no. 10, no. So no, it's prime. Okay, what about 45? Well, it ends in 5, so 5 goes into it, so it's composite. Okay, all right, good. Okay, now let's do some prime factorization with our trees, and then we'll be done with 3.2. So in 3.2, we found factors. We listed factors, and sometimes the divisibility rules will help as you list them until you start going back up the other direction. 1 and 23. Don't forget, when you are listing your factors, make sure you include the 1 times the 80 to give you this. Okay, all right. We talked about what's prime and what's composite. Okay, and again, the divisibility rules can help with that as well. And now we're going to do the prime factorization as our last thing. We'll practice this. Okay, rather than doing the 6, let's do number 19. So 2 numbers multiplied together that give me 120. That would be 12 times 10. Then we're going to keep breaking this down. Let's break down the 12 into, we'll say, 4 times 3. I'm going to cross off the 12 because I broke it down. Then of these two, the 3 is done. It's prime, but the 4 can be broken down into 2 times 2. Okay. So that branch is done. Here, the 10 can be broken down into 5 times 2. So by crossing off, it kind of helps you when you're finally done to see exactly what you've got. So the prime factorization is 2 times 2 times 2. I have 3 of them. 1, 2, 3. I have a 3 and a 5. So you have factors that are all prime, and if you multiply these factors, these prime factors, you will get 120. So you can check it on your calculator. Take 2 times 2 times 2 times 3 times 5, and you've got 120. So you just start out with any two that you know multiplied together, and then start breaking those down individually. Looking at this one right here, or either one. Here, let's do this one. It's a little bit bigger. Looks more intimidating. This is 11 times 100. The 2 zeros mean 100. Just like the 1 0 meant 10. 11 is done. It's prime. This, however, any two numbers that give you 100. How about 50 times 2? Well, yeah, sure. Let's go 2 times 50. Okay. And you could have done 25 and 4 and broke down 25 and 4. It doesn't matter. This one right here, 50 is 25. Oh, let's do 5 times 10. People like that one, maybe then 25. So we'll go 5 times 10. The 5 is done, just like the 2 was done. Here I can cross those off because I broke them down. And this one is 5 times 2. So you just keep breaking them down. And so your answer is we have 2 2s, we have 2 5s, and we have 1 11. So this is an answer MyMathLab should accept, or you could do 2 squareds, 5 squareds. So you have 2 of those, and 1 11. Just like this one could have been 2 cubed. Okay, either one should be acceptable. All right, so that finishes up 3.2. We're going to go ahead and look at 3.3. Even though the video seems to be a little long, I'm sorry. Like I say, you can always fast forward it if you understand something. And otherwise, you can stay with me. This one really isn't too bad. In section 3.3, we're going to talk about fractions, numerator, denominator, and ratios. All right, you know, fraction is composed of a numerator. The numerator is here on the top. Just remember the numerator on the top, and the denominator is on the bottom. I don't know, denominator down. I'm not sure how you can remember that, but you got your numerator over the denominator. And fractions such as, let's do an example. Let's say we have 3/5. So 3 is in the numerator, 5 is in the denominator. And this can also be called a ratio. A ratio is a fraction or a relationship between two numbers. So we're going to be writing some fractions, identifying numerator and denominator, and then we're going to be writing ratios in some examples that we'll be looking at. And we'll also be reducing some fractions. All right, so looking at this right here, we can go through some of these readiness ideas. Sometimes I don't like them, but these ones aren't too bad. The quantity 4/5, that's how that's read, is written in, this is fraction notation. Just to kind of go over the terminology again. In the quantity 4/5, the 4 is the numerator. Okay. In the quantity 4/5, the 5 is the denominator. All right. So together they have a fraction, numerator, denominator. Okay. So real quick, a few more examples. In this right here, the numerator is 7. I'll put an N there. The denominator is 8. Pretty simple. Here, the numerator is 15. The denominator would be a negative 11. And throwing some variables in, 3x is the numerator, 22y is the denominator, no problem. Also, writing fractions. When you write a fraction, the numerator, what object is shaded? The numerator is what's shaded. The denominator is the total number of pieces. And the denominator, the pieces have to be the same, size. And when you're dividing it up into something like this, you can't have one piece bigger. This is a little bit different. They're not the same size, but they're separated, so we can do that. But in a case like this, the pieces do need to be the same size. So what's shaded? Well, we have 1, 2, 3. Our total is 1, 2, 3, 4, 5, 6, 7, 8. We have 3 8s. Okay. Now this one right here, this is going to be interesting, and we're going to practice it on the other side. But here we have, it's a 4 by 4, so we have 16 that are shaded out of 16 total. And when we have 16 out of 16, we say we have 1. All right, a whole. We have the whole thing, one whole thing. In number 9, we have 2 shaded out of 1, 2, 3 parts, 2/3. Great. On number 10, let's see, how many do we have shaded? 1, 2, 3, 4, 5, 6, 7. Out of 1, 2, 3, 4, we have 5, 10, 15. 7 out of 15 is what we have shaded. On number 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that numerator is what you wanted. You wanted the shaded out of the total. And let's say we have 4, 8, 12 total. Now 10 twelfths will work, but also there are times where they may want you to reduce this. 2 goes into both of these. We have those divisibility rules again. 2 goes into this 5. 2 goes into this 6 times. All right. But I believe that my math lab will accept that for now, the 10 twelfths. If not, try to reduce them by dividing them by the same number. Okay. All right, let's look at this one. We have 1, 2, 3, 4, 5 shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9 total. Okay, 5/9. All right, so note how you write a fraction, given a picture of something. Okay. Now we're going to do some things with ratios, and then we're going to reduce. I guess we will practice reducing maybe. Okay, I think it's Shelly. Or Dad. Okay, we'll call her Shelly. Shelly makes hair bows that she sells on Etsy.com. She received 21 orders on Monday and has 5 bows still to make. What is the ratio of bows made to bows ordered? Now, a ratio is a fraction. The numerator is what you read first. The denominator is after the 2. So we want bows made on top. It's what we read first. That's in the numerator over bows ordered. All right, so rather than looking at a picture, we're reading a story problem. What we want, we have bows made, a ratio over the bows ordered in the denominator. The first one you read will always go in the numerator. Then you have 2, and then you have bows ordered. Well, how many bows has she made? Now we're going to fill it in. Well, let's read. How many bows has she made? She received 21 orders on Monday and has 5 bows still to make. That's all we're given. So how many bows has she made? Well, if she got 21 orders and she has 5 left to make, she must have made 16. If I subtract those, she made 16 if she has 5 more to go and she's done. All right, so she made 16. So a little bit of math to kind of figure that out. Bows ordered. How many were ordered? Well, that's a straightforward one, 21. So the answer to A is 16 over 21. This can also be written, since it's a ratio, 16 to 21. Those statements mean the exact same thing. Let's look at B. Bows made. So we have bows made. Here, let me get another sheet of paper. We have bows made. Bows made over, so that's the numerator. The first one you read is going to be in the numerator. To bows still to make will be in the denominator. Bows still to make. Now you won't have to write this out. I'm just doing that to help people understand. The bows made, and we found that for the last one, 16. The bows still to make. How many does she still need to make? 5. 16 over 5. Or 6, oh, I don't know why I put 16 or 15. There's your answer. Great. Let's do the last one. Bows still to make, which is 5. We'll just do this one. Over bows ordered, which is 21. Okay, so it may want a fraction, or it may want as a ratio. That is read 5 to 21, 16 to 5. All right, either I think that it wants a fraction, but just in case, if you see this, they mean the same thing. All right, so I kind of hope that you understand how to do those. All right, and I want to look at one last thing. And we're going to reduce these fractions. Now, before, we now know that 0 over 16, whenever you have a 0 up here, it's 0. But if you have a 0 in the denominator, this is undefined or not defined, depending upon how this book says it. All right, so we got those two down. Let's look at 17. On 17, this cancels with this, and this cancels with this. When that happens, the answer is 1. So in other words, we have 31 out of 31, which is 1. All right. So here, when these cancel, you get a 1. Okay. Negative 54 over 1 is a negative 54. Those two mean the same thing. Let's look at number 20. 0 over 8, which we now know from number 16 is 0. So I did take the 9 minus 9, get 0. 21 is the same as 17. When these cancel here, if you're reducing them or dividing them both by a negative 177, divide by a negative 177. When you reduce those, you're going to get a negative over a negative. You have 2 of them. This is a division. You have 2 of them, so it's going to be positive 1. Okay. All right. Wow. I think that pretty much does it for these 3 sections. It seems a little long, but like I said, it was 3 full sections. Um, let me know if you need any help. I'd be happy to meet with you separately. Okay. Bye-bye.